Thanks for coming today. So we are going to cover rate questions, work questions rather. We did a lot of good rates last week. Work is another, really good topic that can be worked on. And it's one of those things, again, in my opinion, where you can have a really systematic approach to what you're doing. Now, there's two kind of ways people deal with work questions. You've got what's called combined work and you've got combined rate. Now, we do a lot of combined work in our solutions, but the combined rate works just the same. It's just kind of a tomato-tomato situation of what you feel like doing. And the thing is, both of those work pretty seamlessly for a lot of the work problems that you can see. Where people generally run into issues is when they're trying to determine what somebody's rate is. The whole thing where you have to do 1 over somebody's rate versus not, depending on what the work value is. So there is some nuance to these questions, but I want to get into like 3 basic type of work questions, and I want to show you, at least in my opinion, how they're kind of all interrelated. And then, like I said, you guys are going to probably do things a certain way that isn't necessarily the exact way I'm doing these, but I think we're going to still come with the same answers. You can see what you think. I'm going to pull a couple of these from the chapter. If we have time, maybe we'll do a couple trickier ones beyond this, but I want to kind of do rat-a-tat-tat, 3 different ones, and I want to just show you guys these similarities. I think it's kind of cool. So let me put up the first question. This isn't, these aren't going to be terribly difficult, but more so for me to kind of prove a point here. So I'll give you guys a couple minutes and you can work this out. So it looks like, yeah, we have a lot of good answers here, mostly correct ones, almost across the board. So I'm just going to show you my formula that I use. Like I said, you can use combined rate if you want to, but I prefer to use work of A plus work of B as total work. Now, total work can be a number of things. It can be 1 if you're completing a job. It can be 1 if you're emptying a pool. It can be 300 if you're emptying a pool of 300 gallons. It can be 55 if you're building 55 cars. In this case, it's 3/4 because we are filling up 75% of the pool. So now you fill in, we have hose X, we have hose Y, 1/6 for hose X, 1/8 for hose Y. Now, they're working together. We don't know the time, but we know they're working at the same time. So we can call the time T, right? So that gives us T/6, T/8, T/6 plus T/8 is equal to 3/4. Get rid of the fractions here. We're going to multiply everything by 24. That's going to give us 4t plus 3t is equal to 18. 7t is equal to 18, and it's clear that it's less than 3 hours. So does that make sense to everybody? I mean, again, it wasn't the craziest question in the world, but I want to make sure everybody's on the same page. All right, sounds like we're good. Now, I'm going to show you guys another problem, and you're going to see, wow, you're doing the same damn thing with a slight difference. And this is important because the more you can kind of be a machine on the GMAT in certain cases, the better you're going to be. It's just a fact. So why don't you guys take a look at this problem as well? So again, this shouldn't be too bad. I'll show you how to deal with the machine breaking down. That was a question. Now, there's actually two ways to deal with this, but I'm going to stick with the work of A, work of B scenario. Now, in this case, work of A plus work of B is actually equal to 1, right? Because they could end up completing the job. So we have rate times work, we have machine A, we have machine B. Machine A takes 2 hours, that's 1/2. Machine B takes 3 hours, that's 1/3. Now, they each work together for 1 hour, so we can fill in the 1 hour time frame here. But machine B breaks down, so it stops working. That means machine A has to keep working for some unknown amount of time. We'll call it 1 plus T. And then we have 1 plus T over 2. We have 1/3. So if we're doing the math out, 1 plus T over 2 plus 1/3 is equal to 1. Multiply the whole thing by 6. That's going to give us 3T plus 3, I just wrote it backwards, plus 2 is equal to 6. That's going to be 3T is equal to 1. T is equal to 1/3, which is, of course, 20 minutes. Now, keep in mind, they could have asked you, how much total time did machine A work? And I literally just did a video on this the other day. I don't know if you guys have noticed, but on our YouTube channel, we've been adding in a lot of short videos, like under a minute. And they're really cool. And one of the things I talked about was don't put the first answer you see. So for instance, if this problem said how much total time did machine A work, and you got T as 1/3, and you immediately said, oh, I'm done, 1/3 is 20 minutes, well, that would be wrong, unfortunately. And the GMAT does this a lot. There's extra steps sometimes you have to take at the end of these problems. You need to make sure that you know what they're asking for, and if you have to then plug in and do additional work, you do it. I mean, another question off the top of my head is, like, in an age problem, you'll see that you have to solve for someone's age, and then they'll say, well, how old is, Frank in 3 years? And you may solve for Frank's age today and then forget to add 3 years to it. So the point is just make sure you're always solving for the correct answer choice. Back to my original statement. Notice again, we use this formula again. So we're still on track. We've done 2 problems of varying problems that seem somewhat similar, but we use the exact same process. So I want to do a third one and kind of tie a bow on this so you guys can see what I'm getting at here. So take a stab at this. right, so most of you guys are good here. Again, this is another combined work question. Total work being 1, so I'll actually replace TW with 1. We have a rate, we have time, we have work, we have Carla, we have Dan. Dan's rate, well, we don't know his rate, which we'll see, is 1/42 is Carla. Dan is unknown, we'll call him 1/D. They work together for 28 minutes, so Carla's work is now 28/42, which reduces to 2/3. Dan is unknown, so we do 2/3 plus 1/D is equal to 1. You multiply everything by 3D. You get 2D plus 3 is equal to 3D. Just make sure that's correct there. 3 is equal to D. So yes, his rate is 1/3, but no, that is not correct. Something is off here. Let me see where I'm off. 2D is correct, 3 is correct, 3D is correct. Yeah, that would be it, 28/D. Ha. Knew something was wrong there. There we go. So 2/3, 28/D. Good correction there. Now, we still multiply everything by 3D. That gives us 2D plus 3 times 28 is 84 is equal to 3D. 84 is equal to D. So the answer is E. Now, my question to everybody here, minus that hiccup, does everyone see how in each problem I kind of did something similar where I just kind of filled in the information we had here, plugged into the combined work formula. Likewise here, filled in the information I had, plugged into the combined work formula. Filled in here, plugged into the combined work formula. Yeah, I mean, using the matrix, but you know, look, if you're comfortable enough with these problems and you feel like you don't actually need to plug into a table, I'm okay with that too. But I just want you guys to feel and see the similarities between each one of these questions, because the fact is, so many work questions can be done with just such a similar process. And to me, it just makes life easier. You're saying it wasn't clear to you that the rate was simply 1/42. Well, when it says that, okay, well, I think we can all agree that we don't know Dan's rate, and rate is work over time, and loading dishes in this case is the work value. So with that in mind, Dan's rate has to be 1/D, where D is the time it takes him to load the dishes. And for Carla, when it says she can load dishes in 42 minutes, that's implying she can do one job in 42 minutes. Again, rate is work over time, work being the value of 1, 42 being the time it takes her to do the job. Now, if you guys are struggling on how to get these set up, with more practice, these will become very clear to you and they won't be bad. But if you're doing these for the first time, yes, this might be a little confusing. I know we're trying to pack a lot into a little bit of time here. And these take on a lot of components that you learned in rates too. Like, you know, work questions. Remember in rates, we did a problem, I'm pretty sure, where I said, okay, here's a classic rate question where there's two different relationships, a relationship with the time and a relationship with the rate. And you had to basically fill in the chart and get it in terms of one variable, and then use the extra component to get yourself an equation. And it really wasn't all that bad. And work questions can kind of have the same twist to them as rate questions. So a lot of times when you can do one type of problem, you can do the other. So I am going to step up the level of difficulty here. in this next problem to just show you how they can make these more difficult. But again, this shouldn't be anything that you haven't seen either in TTP, well, because this is a TTP question, or in the stuff we've done with distance questions. And if you can handle these, I mean, you're one step closer being able to pretty much handle anything your way. I've never solved a work question using weighted average. So my short response to that is no, I don't believe it can. Or furthermore, I wouldn't try to do that. It just seems unnecessarily complicated. All right, I'll give you guys a couple minutes for All right, well, this will probably be the last question for today, but I guess my question to you guys is, did you find this to be harder than the ones we previously did? Yeah, I would agree it's harder. Now, there's two ways you can deal with it. You can go the simultaneous equation route, or you can just stick with one variable in your table or chart and then use the extra relationship for an equation, which is generally the route that I take. Now, we know that they each fill up the 500 balloons. That's set in stone for both of them for work. So that's an easy thing to fill in first. The next thing is we see that it takes Tom 2 hours longer. So we can either use that or we can use the 50% more balloons in the matrix here. Well, let's say we don't do the 2 hours longer and we do the 50% more balloons. So that means Tom, if we have Jerry as R, we can both agree that he's 1.3R or 3R over 2, right? Now, what that, or, sorry, other way around. I'm just going to flip these. Jerry is the faster person. And then Tom is this person, the R. Now, we have to fill in our time. I'll change the color. That's 500 divided by 3R over 2. So that's going to give us 500 times 2 over 3, essentially. Now, the other person, of course, is Tom, and he is 500 over R. So the thing is, we need to account for who is the slower person in this particular instance, right? Because the fact is that we need to be well aware of where we're adding in our given equation. So when we set up the equation, we'll just call it 1,000 over 3. We have a time of 1,000 over 3R, and then we have a time of 500 over R. Well, the thing is we know that Tom is taking 2 hours longer than Jerry, right? So that means that Jerry's time is faster, which means it's shorter. So what do we do in that case? And that should be 1,000. We add 2 to it, and then we set it equal to 500 over R. And then from there, we basically have the exact equation we need to be able to deal with this. And then it's just a matter of then multiplying through. We see our LCM is 3R, so that becomes 1,000 plus 6R is equal to 1,500, right? Because the R's drop. 6R is equal to 500, and then R is equal to 500 over, oops, fix that. 500 over 6, which is equal to 250 over 3, and that is that's the rate for Tom, and of course we need to get the rate for Jerry, which is basically 3 times that, and that's how we, or excuse me, 3 over 2 times that, and that's how we end up with 125, which is A. So the final step is 3 over 2 times 250 over 3. That equals 125, and there's your answer. Now notice I didn't get into a scenario where I actually divided 250 by 3. I knew that wouldn't work out cleanly, and I don't want to have non-clean numbers as I'm working through the question. It's ugly. It would be tougher to solve. Notice how nice and neat it was when I multiplied 250 over 3 by 3 over 2. The 3's canceled. You divide it by 2, you get 125, and that's your answer. But I want you guys to understand that we didn't do anything that crazy here. We filled in the chart. We got it in terms of variable R, and then we used the fact that we still had this lingering relationship here, and we made an equation. We made one equation with one variable, set these things equal, and we solved. That was it. How did I get the I divided 500 by 3R over 2. That was the time. That's how I got that. When you flip and multiply, yeah, I missed the R here. I should have put an R right there. Yeah. Well, the other way is simultaneous equations. We're not going to get into that now, but yeah, if you wanted to put the 2 hours longer in the chart too, you could have done that. And then essentially each row has its own equation. And then you got to do, then you kind of got to isolate and substitute in. It's kind of nasty. It's not as fun. And there's a lot more happening there. For me personally, I kind of like this method. I feel like there's less going on. As long as you can successfully set up the equation that I set up, then you're good. All right. So any questions for anyone about this stuff? I mean in general, not just work questions, but your GMAT, Target Test Prep, because we're going to be done with the questions for today. I'd say this is we're not recording, distributing any recordings at the moment for these sessions. I don't know. I think this question could be in the low sevens. I think if you don't know work questions, you have a very slim chance of getting this correct. Well, the way we set up the table is Jerry can do 50% more than Tom. So we put in 1.5 R for Jerry and R for Tom, and then they both did 500 balloons apiece. That's why work was 500. And then time is simply work divided by rate. No, I don't have any other questions I can share at the moment. But if you're using Target Test Prep, there's plenty. So hopefully you're using our course and you can work through our work questions that are labeled hard. Any other questions? It's really difficult. I wouldn't worry about the distinction between what when I'm giving you the difficulty ratings. It's not something that even needs to concern you, and it's not really scientific, to be quite honest with you. It's just my gut feeling about what I think is difficult and not, essentially. Yeah, you're welcome, everybody. Any other questions? All right. Well, if that's it for everybody, you guys have a great weekend as well. Stay safe. We'll be here next week. Tomorrow is Marty's verbal session, which I'm guessing some of you will attend. And that's it. We're here if you guys need anything. All right. So be good, everybody, and we will talk soon.